Good afternoon, everybody. How are we all doing? We're going into the second page of Unit 11, Lesson 8. So here's the wonderful first page. Tabitha, I see you created a new name. I think. I'm going to assume that's you. But yeah, so what I'm going to do today is I'm going to do a little bit of review. Exercise number 4 is pretty much review of what we did on the front page. And then I'm going to show you guys how to graph this by hand rather than using the calculator. I think overall you guys are going to feel pretty comfortable with this. It's just one new step, which is kind of an old step that I mentioned on the first page already. Oh, so you forgot your password? That's pretty much what happened. But, so yeah, what I want to do with you guys is... Oh, it's blurry again? What the heck? I don't know what would be causing that, Sierra. That's a shame. Even if you try switching it to like 480p, it's still blurry for you. Or check, I mean 720p 60 where it says source. That would be the best one. But I don't know. Like number 3 that we did yesterday, Tabitha? Or are you saying number 3 on the homework? Because I can go back. That's what I'm doing right now. Oh, that stinks, Sierra. Because as far as your question, Tabitha, if you're talking about exercise number 3 from the previous page, that's what I'm about to be doing again here in example number 4. Yeah, I'm going to do some with the fractions, but I'm going to have like pi in it and stuff. So I'm going to do 4a. The two things, well, I guess this problem's only asking us to find the period. So all I'm asking you to find is the period. Now, this is a formula that technically you do have to memorize, but because we're doing it all online, it's all open note, you don't. But we said that this formula yesterday is represented by P equals 2 pi over B. And we said that we can find the B value inside of this little equation by just locating the number that's in front of the x or the theta or something like that. So I'm going to start off with a, which is a non-fraction, and then I'll go and do one with a fraction so you guys can see what's going on with those. So in this one, if I were to try and find the period, I'm going to have p is equal to 2 pi. Okay, apparently it wants to write a circle. 2 pi over 4. And then you just have to reduce the fraction. So this one's a pretty easy one because 2 over 4 is the same thing as saying 1/2, or I could just write it as pi over 2. So the period is saying that this curve would end at pi over 2. So just remember, all graphs that we've done before this lesson, the period was 2 pi, because 2 pi is one circle. That's 360 degrees. Today and yesterday, we started going into some graphs that don't go 360 degrees. We're saying that it's ending sooner. Sorry, Shannon. Just remember, it's 3 o'clock every day, except for tomorrow. No lesson tomorrow. If we go to part B, now there's only one thing that's a little bit different in part B, and it's just a tiny little thing, and this is probably why Tabitha was asking a question about it. So it's still going to be the same formula. So we'll have 2 pi all over b, and in this case the b is going to be pi over 3. So we're going to have pi over 3. Now, we don't want that fraction on the bottom. So I'm going to show you guys something, and then I'll show you the little shortcut for it. But This is a complex fraction. We solved complex fractions in the last unit. And actually, you know what? I'm just going to show you guys the shortcut now. So, when we did complex fractions, you guys may remember something called LCD, where we would have to get a least common denominator. So, I'm just going to use my little scissor tool and I'm going to move this 2 pi a little bit higher because technically the denominator underneath that 2 pi is 1. So in this case, we would just say that our LCD is 3 because we want 3 on both denominators. So all I have to do now is just multiply the top and bottom fraction by 3. And this is what we did with complex fractions. And I just put it over 1. And then we did something called cross-canceling. So in the top, 2 pi over 1 and 3 over 1, there's nothing that cancels out. So I can just multiply them together. And I will have 2 pi times 3 is 6 pi. On the bottom, you guys should notice that we have 3's that are across from each other. So those are just going to cancel out because they're exactly the same. 3 divided by 3 would be 1. So the only thing that I would be left with on the bottom is pi. And now this could be 6 pi over pi, which is just 6. So yes, Tabitha, this is really just multiplying by a reciprocal because what it's actually saying, this is just a fancy way of saying 2 pi over 1 divided by pi over 3. It was just a fancy way of showing that. And we're multiplying by the reciprocal because we learn when we multiply with fractions, we use that trick, keep, change, flip. So if you prefer doing it the keep, change, flip way, you can do it that way. If you notice what the LCD is, you could just multiply it by the LCD and then it will cancel out as well. It is the same amount of work. It is doing the same exact thing in the long run. Okay? So I'll do it again in part C. It's exactly the same. So I have P is equal to 2 pi all over 2/3. And again, I'm just taking that 2 pi and I'm putting it over 1. And in this case, you guys should notice that the LCD again is 3. So I'm just going to multiply the top by 3 over 1. And I'm going to multiply the bottom by 3 over 1. So as far as this goes, again, there's nothing that can cancel out on the top, so we're just going to be left with 6 pi. All over, again, on the bottom, the 3's are going to cancel out because if you cross cancel, they will disappear. And then we're just left with 2 on the bottom. And now if we have 6 pi divided by 2, it is really just 3 pi. Do we need the number in front? No. So Ella, the numbers that are out front, the 8, 6, and negative 12, that is just our amplitude. So that's going to tell us how high we go and how low we go. The period is asking where does the function stop? So if I ask for the period of a function, it's just saying, hey, where does the curve end? The leading number just is asking how high do you go and how low do you go? So that's the difference between the two vocabulary, and we're actually going to do that in the next question. So we're going to mix both of them together. Okay, so question number 4 had nothing to do with the amplitude. We didn't have to worry about them. Okay. So, as far as number 5 goes, so this is going to be like the shortcut that I said. Now, you can do this in the calculator, but there's one part that you're not allowed to do in the calculator, and that's like this new step. And I kind of mentioned it yesterday on the front page. I'll mention it again today. But what you guys should notice is I did not put numbers on this graph. So Normally, the numbers are written like this. And I'm going to create a table off to the side. Do I want to make a table yet? Shoot, I can't do the table quite yet, but I will start off with this one line. So originally, we start off with theta. Okay? Or in this case, I should call it x, because I wrote it as x in this problem. It is 2 sine 4x. So we're going to start off with x. Now, normally on the table, this is how the x's go. We started with negative 2 pi. We then went to negative 3 pi over 2. We then went to negative pi over 2. And then we went to 0. So again, all I'm doing, if anybody is lost on where I'm getting these 4 numbers from, I'm going to scroll up and then I'll scroll back down. If you look on our graph, notice that I already had the numbers written there. I had negative 2 pi, negative 3 pi over 2. I skipped over negative pi for some reason. I don't know why. Ay, ay, ay. I got to move this down a little bit. I forgot to put negative pi in there. And then we have negative pi over 2, and we have 0. So that was everything on the negative side. Technically, we still have everything on the positive side as well. So when we have these numbers, they actually just go in the other direction, but now we're just going to go up. So it'll be pi over 2, it'll be pi, and I'm going to shrink all this. 3 pi over 2, and 2 pi. So, those are all the numbers that we have had on our grid. Now, we can't use those numbers for this grid. And the reason why we can't use it is because we see that the frequency changes. We see that we have a number next to the x value. So as soon as you see that there's a period change or a frequency change, we have to convert these numbers based on whatever that frequency is. Now on the front page, I wrote this down, but I'm going to talk about it again. We have to recall what happens in transformations. So if we have something that's being done to the inside of the parentheses, we really have to do the opposite operation. So even though that says that we're multiplying it by 4, we really aren't multiplying it by 4. This is really telling us that we're multiplying by its reciprocal. We're multiplying it by 1/4. Because the opposite of multiplying by 4 would be multiplying by 1/4. So before we can actually use our calculator or try to graph this out by hand, what we need to do is we have to convert all these numbers by multiplying each one by 1/4. Now technically we're only doing it 4 times. And the reason why I say we're only doing it 4 times is because we're doing it for the positives and the negatives. So we're going to get the same answer for them. So we're going to get the same exact answers when we go to multiply it out. It's just some are going to be negative, some are going to be positive. So what we're doing, and this is why I created a little table, we found our x, but now what we're finding is our 1/4 x. We're going to find our new x. So if I were to multiply negative 2 pi times 1/4, that's really just going to be negative 2 pi over 4, which essentially is just negative pi over 2. So all I'm doing is I'm multiplying it out. I did it off the top of my head because I put the 2 pi over 1 and I just multiplied straight across. So we just found the new first number on the table. That is negative pi over 2. That's going to be your new start. Now I got to do the next one. So I have negative 3 pi over 8. And that's going to end up staying the same. I can't reduce that. So my next one is going to be negative 3 pi over 8. And I just got to continue this process. If I multiply the next one, it's just going to be negative pi over 4. That cannot be reduced. And if I do the next one, I'm going to have negative pi over 8. And that cannot be reduced. The next part's still 0 because 0 times anything is still 0. And now you're going to realize you don't have to multiply anymore because we already have all those answers. Pi over 2 times 1/4 is going to give us the same answer as negative pi over 2 times 1/4. The only difference is the answer is going to be changing to positive. So when you're doing this out, we don't really care about all the positive numbers down here because we just wrote all those answers right here on our grid. So now I'm just going to take all those answers I wrote down and I'm going to write it on the other side now. So I have the positive pi over 8. I have the positive pi over 4. I have 3 pi over 8. And I have pi over 2. Okay? So we now figured out the frequency. We also figured out the period. Even though we didn't do the formula, we actually just figured out the formula by putting it on this grid. So now if I were to ask you to do the period, I'm just going to show you guys that this number over here should be our period because we're telling ourselves when we drew this graph that that is where it's ending. So I'm just going to write it over here and show you guys mathematically. So I have 2 pi over 4. Hey, if we reduce 2 pi over 4, doesn't that just give us pi over 2? Because the period formula is always 2 pi over b. So we already found the end, so we didn't have to do the period formula again because we already know it. Now, here's the best part. You can do this whole next part in the calculator if you would like. Just like we did the other day, you can go into the calculator, you can type in 2 sine 4x. I can go into the table. I'm just going to delete everything that's there. But now I'm just going to type in the new numbers that I wrote down. I'm only going to do this for one because I'm going to show you guys there's an even easier way. So I'm going to type in negative pi over, oops, I put down 6. I want 2. I'm going to press enter. It says the answer is 0. So I'm going to put a big blob here at 0. So I could keep doing that forever and ever and ever. But there is an easier way by doing it by hand. And this is what Ella mentioned when she said, hey, does that number out front mean anything? Yeah, it does. Because we know that the number out front is representing, oops, I am on pencil and not on highlighter. That is representing our amplitude. So the amplitude, go away. Remember, the amplitude tells us how high and how low we go. So because it's 2, it's telling us that we're going to go as high as positive 2. We can't go higher than that. And we can't go any lower than negative 2. It has to be between those two lines. So I know I have a sine function. We said that sine functions always begin on the midline. So the midline in this case is right down the middle. It's the x-axis. So if I were to graph this midline, it's going to start right there at 0. Now, the sine curve is positive. So because it's positive, it has to go up. So if I'm going up, that means at pi over 8, I'm going to reach the highest point of the graph, which is at 2. And now we're just alternating like we did our graphs the other day. So I went as high as 2. Now I have to work my way back down. So I'm going to come down to 0. And then I'm going to go all the way down to -2. And I'm going to go back up to +2. And then just remember, your graphs repeat. So if I were to draw this in, I should have a curve, and because it's a sine curve, it should kind of, sort of look like an S. Oops, sorry. That was a bad curve. So as you guys can see, this is kind of looking like an S. It's like a sideways S, but your graph always repeats. So I have to just do the same thing on the opposite side. I should be pointing this way for you guys, right? I got to point this way because you guys are going to be doing it on the left side. So now I'm going to do the same thing over here. So again, I start at 0. I'm going up to +2. I'm going down to 0, down to -2, and then back up to 0. So it's the same exact graph, just repeating itself. So the graph pretty much stays exactly the same. The hardest part about this is creating our new numbers. And you can create your new numbers based on whatever the frequency is. So I know that can be kind of confusing. So I'm going to break it down again in the next example. I'm going to do the same exact steps. And we'll see where everybody's at. Because this is how the last question on homework number 8 is written out. Okay? So when I go to create my table, I technically, when I go to do my x, I have my original x's. And I'm going to put down -2 pi, -3 pi over 2, -pi, and -pi over 2. Those are the only 4 we really care about. Because notice when we were at 0, the answer was just 0, and all the positives just stayed the same. What did you type in, Tabitha? Oh, okay. It thought my Nightbot thought you were swearing. How are the 4 S's, or is it different than the cos? There should only be 2 S's that are happening here. Oh, okay. So Tabitha, I understand. So right now, the way we graphed it so we only see one full S. But you have to remember that this graph occurs all the way up to 2 pi. So that it's telling us that you're going to have 4 of those S's. If you keep drawing this out, it would happen 4 separate times all the way up to 2 pi. That's what it means. We're just simplifying the graph and we shrink it down so we can see one curve. That 4 still means it's happening 4 times. But it's happening 4 times all the way up to 2 pi. So as far as this one goes down here, I keep thinking I'm on highlighter and I am not. So I'm highlighting that 1/2. So remember, if it's on the inside of the parentheses, this right here is representing its reciprocal. So we're not actually multiplying by 1/2, we're multiplying by 2. Okay? Because what's happening is this graph is actually getting stretched out. It's going to get really, really long. So if we're multiplying it by 2, we just have to multiply each one of these by 2. Okay? So if I'm multiplying it by 2, that means my new form should be 2 times x. So I'm just going to multiply them out. Negative 2 pi times 2 is really just going to be negative 4 pi. If we did negative 3 pi over 2 times 2, if I put that 2 over 1, we technically could cross cancel, and those 2's are gone. So really, we're just going to be left with negative 3 pi. If we do the next one, negative pi times 2 is negative 2 pi. And I'm guessing you guys are noticing the pattern now, because when you guys go to multiply the next one, the 2's are going to cancel out, and you're left with negative pi. So this one's going to be a little bit easier to graph out, because now I can label all of these on my grid. I have negative 4 pi, I have negative 3 pi, I have negative 2 pi, negative pi. And then when we go to the positive side, we're just changing them all to positives. So I have pi, 2 pi, 3 pi, and 4 pi. So I'm going to check for a midline. I didn't do it the last time. I guess I should have talked about it because, you know, midline is something we talked about the other day. The midline is the number that you're adding or subtracting at the end. Well, at the end here, we're just adding 0. So that means the midline is just going to be the x-axis. So I don't technically have to draw a dotted line in at all, because this is my midline right here. So I'll write it in just for note purposes. But that is our midline, because it's going to be the middle of the graph. From that midline, we have to do the amplitude. So in this case, the amplitude is 4. So because the amplitude is 4, it's telling us that we have to go up 4 and we have to go down 4 from the midline. So if I go up 4, I'm going to be at the top of the graph. If I go down 4, it looks like I'm just at the bottom of the graph. So this time we're working with cosine. So cosine's a little bit different than sine. So sine, you always start on the midline. When you do cosine, you have to start at the positive or negative part of your range. So because this is a positive 4, it's telling us that we want to start at the positive portion of the range. So that means we want to start at the top of the function. If it was negative 4, then we would have started down here on the negative side. So sine will always start on the middle. Cosine will start either on the top or the bottom based on the sign of the problem. Now we just graph this out like a normal cosine function. So if we're starting all the way at the top, we're just working our way down. So now my next one's going to be at the midline. Then I have to go all the way to the bottom to 2 pi negative 4. And then I'm going to work my way back up. So then I have to go back to the midline and back to the top, back to that maximum. So just remember, sine and cosine will always alternate. It's going to go from bottom to top or top to bottom, and it's going to keep doing it. If we did it correctly, it should kind of sort of look like a C. So as you guys can see, it kind of sort of looks like a sideways C. It's not perfect. And we just have to make sure we graph the negative side as well. So we did the positive side. Now if we do the negative side, it's just going to be going in the opposite direction. But again, it should be creating a C over there. Now, according to the period, if we were to find the period, we are saying it's the ending part of this function. So we're saying that it ends at 4 pi. So our graph says it. If I were to do the period formula, so period is 2 pi over b, which in this case is 1/2. we are multiplying it by its reciprocal. If you were to do 2 pi divided by 1/2, it will come out to be 4 pi. I'm not going to show all the work. I'm just going to say, have faith in me. I will not lie to you. Okay? The last one was just a word problem, but I didn't give you guys a word problem on the homework, so I'm not worried about it. It's just asking you, basically, this is the period. It's telling you that the period is 24 because in the ocean, you have high tide every 24 hours. So they would want you to work backwards to figure out what the frequency would be. So you would just say 24. Oh, maybe I should do this out. I think I did give one problem like this. So if we know that the period is 24, we know period is equal to 2 pi over b. Well, we know what the p is equal to. Sorry, Sierra. I'll upload the video and you can just go back and watch that last part. So period would be 24 is equal to 2 pi over b. And now if I'm asking you guys to go backwards and find the frequency, you just cross multiply. Because we're trying to get that b all by itself. So if you cross multiply, this would be 24b is equal to 2 pi. And now I have to get the b all by itself. So what I'm going to do is divide both sides by 24. And we'll have b is equal to, it looks like it'll be pi over 12. So the frequency is saying that it's going to repeat pi over 12 times, which doesn't make a lot of sense unless we're looking at the graph. And that's why I didn't want to go really into the word problem portion of it. I just wanted to make sure that you guys know how to solve going backwards. Because all the other ones we did, we knew what the frequency was, and we had to find the period. So this one, I think there was one question like that one on the homework. It was on the front page, I believe. Yeah, so in number 3. So number 3 is like the last problem in the notes. Okay. Number 4, actually number 4 is the same thing. So number 3 and 4 are like that because this is saying that the sine curve repeats every 2 pi over 7. So again, this is known as your period. And the problem says find the frequency. Okay? So you guys should be able to go through and do that entire homework now. Make sure in number 5 that you guys recognize that you have a midline. Okay, make sure that you recognize you have a midline. Our midline in the notes was 0. But in this one, you're going to have to draw in your dotted line up at positive 3. Okay? So if you have any questions with that, make sure you let me know. I'm setting the due date for this homework on Monday. So you guys have time to meet up with me in Zoom. You can shoot me emails if you need to. But that is all I got. Okay? So, Sierra, hopefully it unfroze for you and you're able to see it. If not, I will definitely send you what I have so you can see it. And then you can go back and watch the video to make sure you understand what I did. Okay? If I don't see you guys tomorrow, I hope you guys all have an awesome weekend. Yeah, that's all I got. So enjoy your weekend. Hopefully it's nice out. Hopefully you guys can get outside. You can do something. That's what I'm going to do. So I will catch you guys all later. See ya.